Hey everyone, I decided to do a series on life meters, energy meters, and various gauges like that. Not sure how many this will stretch on, but there's a lot of little bells and whistles, a lot of iterations. So what I'm going to do is we'll start with the basics and just functionally show you how it works, and then we'll proceed with some of the flourishes from that point. So don't let these folders intimidate you at the bottom. What it is, I'm just using the same Unity project for all my demos now. However, having said that, these will have no impact on what we're doing. As you can see, we're in a clean scene, so you have not missed anything. So for this, there are only two images that we're going to use to begin with. This is the background meter, so we'll drag and drop that into the screen. As you can see, it has like a thin border, and if you want, you could make the background slightly translucent. The full part of the meter will not be translucent, but just to show you how to do that, when you have the object clicked, click on color, and you can just change the alpha, say, down to whatever you want. As you can see, if you're looking at the bar here, the gauge, you can see it's getting more transparent, so whatever looks right to you. Second thing, let's take this meter image. Now, one thing that I did do is I did change the pixels per inch up here before we started. And the other thing is pivot. Pivot defaults to center. We don't want the pivot to be center, we actually want it to be left. And here's the reason why. We are going to change the size of the meter, so the health bar, energy bar, whatever you want to call it. And since it's going to go from right to left, you actually need the pivot to be to the left, because if the pivot is the center, as the bar gets smaller, both the left and the right would contract inwards, and we don't want that. We want it to move from right to left. So you actually have to move that pivot for this to work correctly. So meter will be at order and layer 0, or meter background I should say. The meter itself, just slide that over. Even -2. Actually, yeah, let's do that. Okay. Now the meter, since the meter in the background is 0, you might think that we're going to make the meter 1. We're actually going to skip order 1 and go right to 2, and you'll see why in a little bit. So what's important is that the bar itself is going to be on top of the meter background, I should say. Now, it's a white meter, and you say, well, meters tend not to be white. They're blue, maybe if they're mana, they're green if they're health. So what we're going to do is we start with a white bar, because eventually we're going to change this color based on how much life is left. So let's get right into it. The way you change the size is ultimately, it's a percent. So I've seen a few exceptions, but generally speaking, as HP increases, your meter really usually doesn't increase. Again, there are exceptions, but generally speaking, a meter is the same size regardless of whatever it's being measured, HP, energy, whatever. So that means that what's going on is the change is actually a percent. So if you're looking at hit points, it's your current hit points divided by your maximum hit points. If you currently have 200 hit points and your maximum hit points are 400, that's 50%, which would mean this bar should only be half its width. So that's incredibly important to understand, is that ultimately when you're changing the size of the meter, it's based on percent. Same thing with color. We start off with a white color because that way we can change this to whatever we want. We can change it to green, blue, and red. And again, it's based on percents. So let's get into it. I have this written down in text file. I'm going to copy and paste a little at a time, so don't freak out. We'll go over it line by line. So let's go to, on the meter itself, we'll go to Add Component, New Script, and we'll just call this meter control. As always, call it whatever you want. And also, as I always say, this is one way to do it. This is a way to do it. I'm not saying it's the best. I'm not saying it's only. I'm saying that this is a way to do this. So let's go ahead and open that up. And certainly, pause the video if you need to do some typing, because I'm going to copy and paste this. Alright, so the first thing is we're going to put in the variables, and I'll go through these one by one. So first one, static. It's a public static float. So this allows for decimals because it's float. Static means that regardless of what object in what scene, this variable will be available. And that's your max hit points. So public static float, max hit points, and we'll set that as 100 to begin with. Public stat float, same thing. Again, allows for decimals. Static, again, it will be available anywhere in the application, regardless of object, regardless of scene. And your current hit points are equal to your max hit points. Total time. We are going to avoid a bunch of checking of collisions or keystrokes or whatever you're going to do in your game. We're just going to show this happen over time. You're just going to have to replace the time mechanic with your collision mechanic. The next three all go together. Public float, if you notice, these are not static. They don't have to be. Green color is set to 1. Again, 100%. It ranges between 0 to 1, so it's a percent. Public float red color set to 0, and public float blue color. So let's go back to the object to begin with. So here's the meter. The color, okay, if you notice, it ranges from 0 to 255. So if this is your first start at programming, that's the range, 0 to 255. So 255 would be 100%. So even though these are using numbers here, in the code you're using a percent. So this means what we currently have here means that we want 100% of the green, and that we're going to use 0% and 0% of the red. So the white is going to turn a green color. Now these are just variables. They don't actually do that. We're going to add in a color statement that does that. Okay. Alright, so public float green, public float red, public float blue. Public transform dam meter. We are a little bit later going to add a second meter, so this is not used for now, but just so we don't have to jump back here, this is going to be a transform type, which means this is going to be an object as opposed to a value. And let's see. We're going to, in the update section, start putting in some code now. So for now, we'll remark that out. We'll get back to it. So what we're doing here, as I said, for simplicity's sake, we're simply going to make the change based on time. So here's that variable, total time. Total time is incremented, that's what that means, by time.delta time. So if you haven't watched any of my other videos, delta time is the change in time. So how much time has passed since the last time this was run? So take the total time and add the change in time. So in other words, this is a running queue. If total time, so again that variable, is greater than 0.7, this is 100% arbitrary. So if total time is greater than 0.7, then we're going to make some changes. Your current hit points are reduced by 5. Okay. So current hit points minus equals 5. Total time is reset to 0. In other words, we want this to happen every 7/10 of a second. And this is completely arbitrary. And then, like I said, we'll get to the start coroutine later. Okay. So what we've done now is we've taken the hit points and reduced them, and that's and then this just lets us restart the cycle. So now let's see what we're going to do with those hit points. We are going to now take this. what this does, so get component, whenever you have an object, it is comprised of components. See how it says add component? It's not a coincidence that the word is the same. Transform component, sprite renderer component, the script component. So what I'm saying is get component. Which component? We're going for the transform component. Okay, what is the attribute of that component? We're going for local scale. So the name is a little bit different. The component here just says scale, but it's local scale. So get component, transform the local scale. Local scale is x, y, and z. So new vector 3. Now this is what I was talking about. So first of all, the entire vector 3 has to be within parentheses, and then this calculation has to be within parentheses. So your x value, so your horizontal, your x scale is a calculation. Current hit points divided by max hit points. So let's do the math. Max hit points start off as 100. Current hit points start off as 100. We reduced it by 5, so that means you now have 95 hit points out of 100 hit points. Easy math, 95%. So in other words, this value will actually be set to 0.95. So new vector 3, x scale is 0.95, y scale is 1, z scale is 1. So these are both 100%, but the x will shrink by that amount. Well, will be set to that amount, excuse me. So we save, and we run it. And at every 7/10 of a second, it decreases. Okay. Now let's add color. Because we already put the variables in up here, green, red, and blue, when we put in our color statement, we're going to use those, and it will already set it to green. So let's take a look. Again, get component. This time, what component? The sprite renderer. So we got our component, got our sprite renderer, and the color attribute. And this time it's new color instead as opposed to a vector 3. And we're using red color, green color, blue color. These variables up here. Red is 0, green is 1, blue is 0. So in other words, no red in this image, 100% green, and no blue, which makes it green. So let's save that and run it again. Now it's green.